Welcome to our presentation on quantifying the carbon footprint of electric vehicles in sustainable urban mobility. This research is a collaborative effort to understand how electric vehicles can contribute to a greener future. Transportation is responsible for nearly 24% of global CO2 emissions, highlighting the urgent need for decarbonization in this sector. Electric vehicles offer a promising solution to reduce greenhouse gases, but challenges remain in grid carbon intensity and charging. Standardized metrics often miss real-world driving conditions, and real-time emission data is scarce. However, Edge AI provides a pathway for embedded, real-time emission inference, addressing these limitations. Our TinyML solution leverages on edge CO2 estimation using parallel models on OBD-II devices. This approach allows for real-time estimation of emissions, providing valuable insights into vehicle performance. Our methodology involves a comprehensive workflow from data acquisition to model deployment. Each step is crucial in ensuring accurate and reliable emission analysis. We acquire data from various vehicle models, including the Volkswagen Polo and BMW i3, using Connected-2 AI and IEEE data port. This diverse data collection is essential for robust analysis. Pre-processing involves cleaning and normalizing data to ensure consistency, while feature engineering focuses on deriving relevant features to estimate CO2 emissions accurately. Variable selection is key to accurate model predictions, and our model architecture is designed to cater to both electric and combustion vehicles, ensuring comprehensive analysis. We implement and benchmark various machine learning models, converting the best into C++ for embedded deployment. This ensures real-time CO2 estimation on microcontrollers. Our evaluation of machine learning models focuses on performance and efficiency, ensuring that our solutions are both effective and practical for real-world applications. Real-world data shows a 95.06% reduction in CO2 emissions when transitioning from combustion vehicles to electric vehicles, underscoring the environmental benefits of EV adoption. Our embedded TinyML solution achieves impressive inference speed and low power consumption, making it ideal for real-time CO2 monitoring in various applications. Our work provides real-time monitoring of urban emissions and quantifies the benefits of electrification. Future directions include expanding sensor integration and exploring federated learning to adapt models for diverse scenarios. Thank you for joining us in exploring innovative solutions for future cities. Together, we can ignite progress and create sustainable urban environments.